Okay, let's talk about decimals. That topic that can be a huge stumbling block in pretty much any math class. For years, we've been teaching with tricks and shortcuts, but what if there's a much better way? Today, we're going to dig into a single, unified system that makes decimals make sense, a way to move past all the confusion and get to real, solid understanding.
So here's the game plan. First, we're going to bust a massive myth about what decimals even are. Then I'll introduce you to the 4 pillars framework. This is the powerful part. After that, we'll see how this framework gives us a totally foolproof way to compare numbers, and the real secret to getting alignment right every time. And finally, we'll wrap it all up with how you can take this tool and use it in your own classroom. Ready? Let's jump in.
All right, let's get right to it. Section 1, Rethinking Decimal Numbers. And we're going to start by busting a common myth.
So I want to start with a question for you. Just think about this for a second. When you teach math, do you treat whole numbers and decimal numbers like they're two different things? Your answer to that question is really the key to everything we're about to cover. You know the common idea, right? That decimals are this whole other category of numbers, the ones with a dot. This one little idea is the source of so much confusion for our students. And I'm here to tell you that idea is completely, fundamentally false. So here's the big aha moment. There aren't two different number systems. There's only one. A whole number, like say 5 or 27, is just as much a decimal number as 12.5. They all follow the exact same rules. And once your students get that, everything changes.
And that brings us to the unified framework itself. This is what holds that whole system together. So let's explore these 4 pillars that support every single number your students will ever see.
Okay, pillar number 1 is the easiest one. It's just the digit. That's the symbol, right? The drawing we make for 0 through 9. So in a number like 537.4, the digits are just 5, 3, 7, and 4. These are simply our basic building blocks.
Now, pillar 2, this is where things get really interesting. It's the position name. And it's not just a location. Think of it like a family name or a category. So 3/10 is just like saying 3 apples. It tells you what kind of thing you're dealing with. And we all know you can't add apples and oranges, right? You can only add things from the same family. This idea is an absolute game changer. And this leads us right into pillar 3, the position value. This is the actual numerical worth of each of those columns, of each of those families. And it always follows one simple rule. It's a base 10 system, meaning every position is 10 times bigger than the one to its right. So you have the ones column, the tens column, the hundreds, and on the other side, the tenths, the hundredths, and it goes on forever in both directions.
And finally, pillar 4, which brings it all home, the digit's value. This is the true quantity, the real power that a digit has inside a number. You just multiply the digit by its position value. So, in our example, 537.4, that 3 isn't just a 3. Its value is 3 times 10, which is 30. And that 4 after the decimal point, its value is 4 times 0.1, which is 0.4.
Okay, so now we have our 4 pillars. Let's put them to work. Let's see how they give us a completely foolproof way to handle one of the trickiest things for students, comparing decimal numbers. The method is just beautiful. It's so simple. And it all comes down to pillar 4, the digit's value. All you do is start at the very left of each number and compare the value of those digits. If one is bigger than the other, boom, you're done. That number is bigger. If they happen to be the same, you just take one step to the right and you do it again. So let's try it out on a classic trap question. This is the one that gets kids every time, right? Which one's bigger, 64.2 or 64.18? A lot of students are going to jump and say 64.18 because they see 18, and they think, well, 18 is obviously bigger than 2. Let's see what our pillar method tells us. Okay, let's do it step by step. We start on the left. The 6 is in the tens place in both numbers. Its value is 60, so we're tied. We move to the right. The 4 is in the ones place. Its value is 4. Still tied. Okay, one more step to the right, into the tenths place. Now, in 64.2, that digit's value is 0.2. In 64.18, its value is 0.1. And right there, we stop. The game is over.
So the conclusion is crystal clear. 0.2 is greater than 0.1. That means 64.2 is the bigger number. It doesn't matter at all that there's an 8 later on. The second we found a difference in the digit's value, the comparison was finished. This method completely avoids that visual trap of 1/8 versus 2. It's all based on true value, not just how the symbols look.
All right, next up, let's use this framework to solve another huge headache, getting numbers lined up correctly for adding and subtracting. And the secret here? Well, it's all about pillar number 2. Remember that family name analogy, the apples and oranges? Well, this is the golden rule of arithmetic. You can only add apples to apples, tenths to tenths, hundreds to hundreds. You can never mix and match. So the rule isn't line up the dots. The real rule is line up the families. And just look what happens when we do that, when we align by position name. Let's say we're adding 975 and 34.86. We're not looking for the decimal point. We're just putting the 5 and the 4 in the same column because they're both from the ones family. We line up the 7 and the 3 because they're both tens. And when you focus on lining up the families, guess what? The decimal points automatically fall into a perfect line. It's not a trick, it's just a logical result of how the system works.
So, let's wrap this up. What does all this actually mean for you and for your students? It means you now have a new, incredibly powerful tool, a single, unified system to teach all numbers.
So what's the big takeaway here? It's this. Stop teaching 2 different kinds of numbers. There is only one system. And the 4 pillars, they're the keys to unlocking it. This framework doesn't give you little tricks that can break. It gives you a foolproof, logical method that builds real, deep understanding that's going to stick with your students.
And that brings me to the last thing I want to leave you with. It's a question. Now that you're thinking about this one system idea, about these 4 pillars, how is this framework going to change the way you plan and teach your very next math lesson?